Hi to all. In this video, we are going to see about design of ampere conductors. Okay, ampere conductors is nothing but the conductors which will be wounded in the machine, DC machine, and how it will be generate the that magnetic circuit in the particular things. The things we are going to see in this design of ampere conductors. The different parts of the DC machine's magnetic circuits per pole are yoke, pole, air gap. See here, in this yoke having some magnetic circuit and pole having magnetic circuit, and air gap is also having magnetic circuit. So the different parts of the DC machine magnetic circuits are pole or yoke, pole or and air gap, armature teeth and armature core. So everywhere the magnetic will be present. Therefore, the ampere magnetic circuit, the sum of the amperes, that is AT by pole. AT is the ampere conductor. Ampere, okay. AT Y means yoke. Okay, plus AT P. Here P is nothing but number of poles, plus AT G. G is nothing but air gap. Okay. See in this diagram, they mentioned, okay, yoke, this part is called yoke of the machine. Pole, second one is pole. This one, yes, n n. These are the things are called poles. Air gap is nothing but the gap between uh, stator and rotor. Okay, this will be the stator. The poles which is present here, no, that is stator, and this armature is the rotor. So the gap between these two, the three, see here, the gap between this is called air gap. Armature teeth. Okay, here armature slots will be present and the coils bounded around this um, slots. Okay, so this is called armature teeth. Okay, and leakage flux, because the total flux which will be generated or created in the circuit will not be a useful flux. Some of the flux will be wasted, or that fluxes are called leakage flux. See here the sixth one, the leakage flux which will be generated here, here, and it may here also and here also. Okay, that flux should interact with the armature. That is called useful flux. When the flux will not be interact with the armature, then that type of flux are called leakage flux. That is not a useful flux. Okay, to overcome that, we are going for interpoles. Okay, interpoles, what we made here, the place of between this pole, this is the main poles, north, the four poles is the, no, there are another four interpoles will be placed between this poles to get uniform magnetic field around the armature. Okay, so AB, mean length of the flux path corresponding to one pole. Magnetic circuit of a 4-pole DC machine. See here, yoke, pole, air gap, armature teeth, armature core, leakage flux AB, mean length of the path corresponding to one pole mentioned here. Okay, the magnetic circuit of a 4-pole DC machines. Okay, because this is a 4-pole, the main poles only consider for the considerations. So all the flux produced by the pole will not pass through the desired path, that is air gap. The flux, all the poles, these four poles will create the magnetic flux. The total flux will not be useful flux used by that one. Okay, air gap. Some of the flux produced by the pole will be leakage away from the air gap. Okay, here also some of the flux will be present. That flux is not a useful flux, and that flux is called leakage flux. The flux passes through the air gap and cut by the armature conductors is the useful flux. And that flux that leaks away from the desired path is the leakage flux. So the flux pi p is the pole flux which will be generated or created in the number of poles, that is equal to pi is the useful flux plus pi l is the uh, leakage flux. As leakage flux is generated around 15% to 20% of the useful flux. So pi p is equal to pi plus 0.15 to 0.25 flux. So we can rewrite that same equation LC into pi. Okay, where LC is a leakage factor or leakage coefficient and lies between 1.15 to 1.25. Magnetic flux of the different parts of the magnetic circuits are flux in the yoke. Okay, I told no this one flux in the yoke. Second one flux in the pole. Here this is the poles, so flux in the pole, and third flux in the air gap between armature and that poles. Okay, and fourth one flux in the armature teeth. Here this is the armature teeth, flux in that armature teeth, and flux in the armature core. In the teeth we are under the armature coil or core. Okay, so reluctance of the air gap is the thing there. So firing flux armature flux distribution under a pole, here pi into tau. So where Lg length of air gap, T with over which the flux is passing in the air gap, L axial length armature core, Yt L air gap area per pole over which the flux is passing in the gap. So from this we came to know some of the flux will be useful flux which will be generated, and some of the flux will be um, leakage flux. The flux will not be interact with the armature. That fluxes are called leakage flux. Thank you.